All right, welcome back. We are going to do this quiz review. We are looking at the quiz for quarter 3, quiz 3, quarter 3. And the first question says, if you are shown a graph of a polynomial, how can you tell what the possible equation is? And the best way for me to show you guys this is to actually give you an example. So if I give you this polynomial, okay, and it's going to go through this one, and it's going to go through here, and here, and here. Now, on an actual graph, you guys will be given these points. I'm making up these points, so I'm going to say that this point is 7, 0. That would be negative. I'm going to say that this point is negative 1, 0. This is 1, 0. And this is positive 7. Okay? Because of the shape of this, you know that this is going to be a 4th degree. The end behavior for this is up, up. Because it's up, up, and it's an even degree, our leading coefficient is positive. Okay. A possible equation, knowing nothing else but this, all you're going to do is you're going to write in these numbers. So if this is negative 7 here, it would be x plus 7. If this is negative 1, it would be x plus 1. This is positive 1, so it's the opposite, so x minus 1. And then this is positive 7, so it'll be x minus 7. So this is one possible equation for this polynomial. Write an equation, y equals x squared plus 6x minus 4 in graphing form. So graphing form, the first thing that we're going to do is we are going to separate the 1, the negative 4, the 1's category, from our other 2. Next thing we're going to do is we're going to draw it out. When in doubt, draw it out. So we have 1x squared. This is positive. And then we have 6 x's. So I'm going to put 3 x's on this side. And I'm going to put 3 x's on this side. In order to complete this square, this missing portion, it's going to be 9 1's. If I add 9 here, I must subtract 9 here to be able to keep it equal. Essentially, by adding 9 here, subtracting 9 here, I have added 0, but in a meaningful way. So this, if I factor this out, it's x plus 3 times x plus 3. So my entire equation here is going to be y equals x plus 3 squared minus 13. So that's my graphing form. So I can just transpose that or transfer that over here. Plus 3 squared minus 13. My vertex is opposite of this and then this. So opposite of h, k. So negative 3, negative 13. Notice I changed the sign. It's opposite of h, but I kept the sign on k. Your axis of symmetry is always the x coordinate of your vertex. So x equals negative 3. What that means is that's going to be that imaginary line that runs straight down the middle of your parabola. Okay, that's your axis of symmetry. That line, that imaginary line that your parabola can fold over and be exactly the same. Okay, your roots. Okay, all that means, friends, is you're going to solve for x. So if I put in 0 and I solve for x, I'm going to first add 13 to both sides. So now I have 13 equals x plus 3 squared. Then I'm going to take the square root of both sides to get rid of this squared. And so now I have x plus 3 equals plus or minus the square root of 13. Finally, I'm going to solve for x. So if x equals negative 3 plus or minus the square root of 13. Because of that plus or minus, that gives me 2 roots, which aligns with my 2nd degree polynomial, or trinomial in this case. And so, have a good day. Negative 3 plus the square root of 13 is one of your roots, and negative 3 minus the square root of 13, comma 0, is the other root. These are the roots when y is 0. Your y-intercept. So now we're going to solve for when x is 0. So y equals 0 squared plus 6 times 0 minus 4. Well, this is 0 and this is 0, so all I'm left with is negative 4. So when x is 0, y is negative 4. Next one, we have 2 to the 2x minus 1 equals 16x. Well, friends, another way to write 16 is 2 to the 4th power. So now instead of 16 to the x, or 16 to the x power, I have 2 to the 4th to the x power. Power to a power, I multiply. So that reduces down to 2 to the 4x. Well, don't forget I still have over here 2 to the 2x minus 1. When I have same bases, which is my 2, and they equal each other, I can set my exponents equal to each other and solve. So 2x minus 1 equals 4x. And I'm just going to solve for x. Subtract 2x from both sides. Negative 1 equals 2x. Divide by 2. X equals negative 1/2. And that's all we're doing for this one. For the next one, we have 3x cubed plus 2x squared equals 6x. So 3x cubed plus 2x squared. I'm going to bring that 6x because it likes to be with its friends and family. And now that equals 0. I just subtracted 6x from both sides. The first thing I'm going to do is I'm going to factor an x out because notice I have an x, 3x is here, 2x is here, and 1x here. So that leaves me 3x squared plus 2x minus 6 equals 0. Now, many of you guys in class today tried to factor this, and I love that you went to factoring first because factoring is time effective if it works. However, this is not factorable, so we do have to use that quadratic formula where a equals 3, b equals 2, c equals negative 6. So it would be negative 2 plus or minus the square root of 2 squared minus 4 times 3 times negative 6 all over 2 times 1. I'm sorry, 2 times 3 because it's over 2a. So reducing that down, you have negative 2 plus or minus the square root of 4 minus a negative, whatever 24 times 3 is. I should do that because that's 3 days. 24 times 3 is 72. So 72 divided by 6. Okay. And so that would be add that. So we have negative 2 plus or minus the square root of 76 over 6. I don't know that you can reduce the square root of 76. Let's try. I don't think you can. Oops. Oh, it is reducible. So that's going to equal negative 2 plus or minus 2 square root 19 over 6. Now this brings us to a kind of a fun thing here. You have negative 2 and a 2 and a 6. If all three of these numbers can be reduced outside of the radical, then reduce them. So that means that you would have negative 1 plus or minus the square root of 19 over 3. So these are 2 of your roots. Your third root is 0. This x over here, x equals 0 is one of your roots. So x equals 0 and x equals negative 1 plus or minus the square root of 19 over 3. Now I know I did that kind of fast, so if you need to pause it and take a step back to figure out how I got what I got, go ahead and do that. If you still have questions, go ahead and email me on that one. All right, number 4, it says a unit circle has an angle theta in standard position, point P on the circle is on the circle, and the coordinates of P are shown. What is the cosine? So remember, ladies and gentlemen, when we're looking at a point on a unit circle, it is cosine theta, sine theta. So the cosine of this point is negative square root 3 over 2. The sine is negative 1/2. What is the measure of the angle theta? So taking a look at your unit circle, you might notice that this is a reference angle to 30 degrees. Okay, so if this is 30 degrees, you have a reference angle here and a reference angle here. Okay, if this is 30 degrees here, this is 180 degrees. And then this part here, this angle here, is also 30 degrees. So this whole angle is 180 plus 30, which is 210. So it's 210 degrees. But oh, by the way, it actually says in radians too. So the way that you find out in radians is you take the angle measurement, 210, multiply it by pi over 180 degrees. Okay, your degrees will cancel. You're left with 210 pi over 180, and that can reduce down, friends. 210 divided by 180. If you don't have one of these calculators, you can reduce that down by hand as well. Immediately, you guys, oh, by the way, I never finished this, sorry, fraction to decimal. So 7 over 6, which equals 7 pi over 6. So let's say that you don't have a spiffy calculator, one of these little TI, what is it, TI 30XS. These are great tools. They're about 15 bucks. But let's say you don't have that, and believe it or not, your big old Mama Jamma TI 84 doesn't simplify like this. Annoying, I know. So you have 210 divided by 180. Immediately you can say, oh, well, I can cancel those zeros out, which leaves me with 21 over 18. Both of those are divisible by 3. 21 divided by 3 is 7. 18 divided by 3 is 6. And then we cannot forget the pi. So we get the same answer, 7 pi over 6, both ways, one by hand, and one with the calculator. All right, number 5, use your calculator to view the graph. So first, let's do that. Okay, now I do have this already typed in, negative 4x times x minus 4 times x minus 3 squared. But when I graph it, it looks kind of, well, ugly. That does not help me. This is not a helpful graph. Now, on the quiz, I will give you the window measurements if you need them. But for now, which I don't think you will. Actually, no, you won't. I know you will not need the window measurements. But for this problem, the window measurements will be convenient. So I want you to change your window settings to negative 6, 6 for x, with the x scale of 1. And your y min, I want you to change it to negative 100, y max 500, and graph. And there's our graph. Right away, you should notice some things. First thing here, I'm gonna actually zoom back out. Okay, first thing that you guys should notice is this is, the end behavior is down, down. it goes through here and here, but what happens here, friends? Yes, that's right. That's that 2-year-old in church. That is a bounce. But you know that by looking at the equation. That's right here. There's our bounce. So notice here, this is where that 4x is. That's this one here. Here, we have x plus 4. So if you set that equal to 0, it would be x equals -4. That's this point. And then we have that bounce at +3. So that means this is a 4th degree. This is a polynomial, because if you multiply this out, it would be a poly. Now, it's going down, down, which means that my leading coefficient is going to be negative, which we know. How do we know? Because this is my leading coefficient, this -4 right here. And my roots are going to be 0, -4, and +3, just like we saw on the calculator. So we did degree, orientation, and roots. I think that's good. Number 6, I'm going to skip this for right now and we can come back to it. Number 7. Number 7 is great. We have the square root of 80. So remember when we were simplifying these square roots, I said your best bet is to list out some perfect squares. So 4, 9, 16, 25, 36, 49, 64, 81, and 100. You can go on if you want to. Nothing is bigger than 80 in our list. And then the best thing that you're going to do is you're going to try your best to find the biggest perfect square that goes into these numbers evenly, divides in. So how can I break down 80? Well, certainly it's not going to be 81 because that's bigger, right? So 80 divided by 64, nope. That's not going to work. 80 divided by 49, oops, 49. Nope, that's not pretty. You'll see what I mean by pretty. 80 divided by 36. Nope. 80 divided by 25. Oh, we're getting closer to pretty, but we're not quite there yet. 80 divided by 16. Oh, there we go. That's what I call a pretty number, which means that 80 can be rewritten as 16, the square root of 16 times the square root of 5. And then we know that the square root of 16 is 4. So 4 square root of 5. Now let's do the same thing with 8. 8, square root of 8 can be rewritten as the square root of 4 times the square root of 2. The square root of 4 is 2. And we still are left with this square root. Square root of 32 is the same as saying square root of 16 times the square root of 2. The square root of 16 is 4, and we're left with that square root 2 underneath. This is kind of a trick question, friends. This is simplified. There are no perfect squares that can multiply or divide through evenly to get this any more simplified. 18. Square root of 9 times the square root of 2. Square root of 9 is 3. And we're left with 3 square roots of 2. And last but not least, we have the square root of 12, which is also the square root of 4, times the square root of 3, which is 2 square root 3. Oh man, friends, we're getting close. These are those rules of exponents. If you don't have the rules of exponents, I would beg of you to please put a learning log entry into your learning log about the rules of exponents. Here we have R2 on top, R3 on the bottom. And so that's going to be 1 over 2r to the first power. I got that by saying r squared. The 2 is going to stay on the bottom. Minus 3, which is r to the -1 over 2. That -1 has, because I need positive exponents, so that r to the -1 has to be brought down to the bottom. Okay, next one. We have x to the negative 1 divided by 4x to the 4th power. So we have x to the negative 1, minus 4 over 4, which equals x to the negative 5 over 4. Remember, we want that negative exponent to be in the opposite spot. Right now it's in the top, so I want it in the bottom. So it's 1 over 4x to the 5th power. C. Wow, look at that. 3 divided by 3 is just 1. So now I have n to the 4th power minus 3, which is n to the 1, and that's your answer. D. Look at that. M to the 4th divided by m to the 4th, that's just 1. That leaves us with 1/2. E. I know I gave you a lot of them, but they do go rather quickly. So E, we have 3 times m to the negative 4 minus 3, which is 3m to the negative 7. Remember, we don't want any negative exponents, but the 3 is not negative, or doesn't have a negative exponent. And so we bring that m to the 7 to the bottom, but leave that 3 on top. All right, last but not least, for the exponents, we have 2/3. We can't reduce 2/3, so we're just going to keep it 2/3. Then we have x to the 4th power divided by x to the 2nd power, so 4 minus 2. The y's, we have y to the negative 4 minus 3. Oh, minus a negative 3. Got to watch my sign there. And z to the negative 3 minus a positive 4. It'll stay 2/3. X squared stays on top. Y to the negative 1. Look at that. And z to the negative 7. Now, I don't want negative exponents. Again, we're going to leave that 2/3 where it is. It doesn't change. My x squared does not change. My y gets brought to the bottom. Your exponent becomes 1. And my z also goes to the bottom. Exponent becomes, oh goodness gracious, that was supposed to be 7, not 4. There we go. Thank you for some whiteout. If you're going to do math and pen, these are your best friends. That almost rhymed. Mrs. Ryden would be proud of me. All right, ladies and gentlemen, we have 4p minus 1 squared. Let's go ahead and multiply that out. 4p minus 1 times 4p minus 1. That's 16p squared minus 4p minus 4p minus plus 1. Combining like terms, that's 16p squared minus 8p plus 1. Let's do it over here. We have 7x minus 6 times 5x plus 6. 7 times 5 is 35. X times x is x squared. 6 times 5 is 30. We have x. 7 times 6 is 42. Oh, I forgot my negative on this one. X. And then 6 times negative 6 is negative 36. Reducing your like terms or combining. 35x squared plus 12x minus 36. So we have 2x times negative 2x minus 3. 2x times negative 2x is negative 4x squared. 2x times negative 3 is negative 6x. There are no like terms to combine. That's just your answer. Next one, we have 4 times v plus 1. 4 times v is 4b. v, 4 times 1 is 4. Again, there's no like terms to combine. That is your answer. Two n plus 2, 6n plus 1. 2 times 6 is 12, n squared times 12n. 2n times 1 is 2n. 1 times 2 is 2. And then we'll combine our terms. 12n squared plus 14n plus 2. Same thing. 4n plus 1, 2n plus 6. Oh, I forgot the pluses here. 2n times 4n is 8n squared. 2n times 1 is 2n. 4n times 6 is 24n. 6 times 1 is 6. Combine your like terms. 8n squared plus 26n plus 6. Oh, sugar. On D, I apologize. This was supposed to be negative. I just missed that negative right here. I apologize. So this is negative 4v, and this is negative 4. So negative 4. 12x, just checking my work. Ladies and gentlemen, that's it. That's your quiz. Now, I did say that I skipped number 6. The only reason is it says a new classmate is planning to join our class. Use a clear example and explain how we can determine the nature of the roots of a polynomial and give an example. Guys, don't go hard on yourselves. Draw a parabola. Okay? The roots are where the graph. Now, to say polynomial, I will accept a trinomial here. Which is also the function crosses the x-axis. So let's say that this is -2 and this is +4. So that means that my roots for this polynomial would be exactly what I said, -2 and +4. However, the equation would be x plus 2 times x minus 4. And then we would say function of x. And that's all I would ask of you. So explain how, roots, example, function, graph. Any questions on that? I will be here tomorrow morning, early, 7:45, barring any household gorns and emergencies, but I can't think of any. You guys have a wonderful day. Happy studying.